Hello, ME250. Today I will be presenting Project 2. We are Section 1, Group 1, also known as the Weasels. My name is Claudio Luis Sanchez. Let me proceed. Now we have a problem. What is the problem? The problem is we want to design a box that is able to open without any human or animal intervention. What does that mean? That means we don't want to put our fingers on the box and physically open it. We want some sort of mechanism or coding, such as Arduino, to open the box by itself. We don't want our hands to open it. We also want it to be pleasing to the eyes. We want it to look nice, be simple, and be straightforward. Let's proceed. Objective and metrics. Our primary objective is to design a box that opens without direct intervention, as stated in the previous slide. This breaks up into four categories. The first one being marketable. We want it to be practical, sturdy, efficient. Practical meaning we want the box to be simple, not some outlandish thing that's made from outer space. We want it to be simple. You are young designers that are making a box that is simple, sturdy. Although it's simple, it cannot be some feeble box that can break in a matter of 2 seconds. Efficient, meaning we should be able to make the box in a matter of, a week, a day, not too long where it takes 2 years, or 4 years of college. The next one is appealing. We want that box to look nice, aesthetically pleasing. What does that mean? That means we want the box to look simple yet beautiful. The box should be unique. Someone should look at it and be like, that box is pretty beautiful. Not some box that's made from the garbage disposal, something made from the trash. No, we want it to be simple. The third one is cost effective. What does that mean? We want it to be affordable. We want it, so let's say hypothetically we distribute it to the mass public. We want it to be affordable, not some box that's worth $1,000, 3 grand. We want it to be affordable. Let's say 20 bucks. A box that is 20 bucks is appealing to people. It's pretty cheap, not that expensive. Simple as it is, safe, eco-friendly, no injuries. Eco-friendly meaning that we make a box that is, safe to the environment. We don't want to make a box that's harming the environment. We want the status to be, this box is simple, affordable, and eco-friendly.
Continuing on, when designing a product, there are limitations or boundaries that can and cannot be crossed, which really limits the design process as a whole. As a team, we went through the project two rules and determined which are the vital constraints. Viewing the table below, we found that the box must be opened without direct intervention, meaning we cannot directly open the box with our hands, for example. Also, at least one part of the box must open and one part must move. The opening part must be opened by a trigger. Whether it's mechanical or electrical, some sort of trigger must activate the box to open. Opening parts must remain attached to the box, meaning that this box must be one whole piece, meaning all the parts must be connected to one base. Also, the box must be able to be created as a 3D model on SolidWorks, revealing that our design cannot be super complicated, as we will have to create a model with the brief knowledge that we have with SolidWorks. Lastly, the box should be marketable. This box should have a purpose in the world, and the team knew that we have to design a product that will be relevant and useful to people's lives. Moving along, we have our primary function is to open the box. We have our electrical designs and our mechanical designs. Our primary functions would be, for example, transfer of energy, and our function means would be servo motor, DC motor, and stepper motor. Powering the Arduino is just another primary function, while our means were 9V battery or a USB. Also, carrying out the signal electrically is also a primary function, and our means were the computer and breadboard and wires. Another primary function is signal to open. We used photoresistor, button, joystick, or ultrasonic sensors. And lastly, the primary function was to communicate to the hardware, which we use in the means of code and software. On the other side, in the mechanical designs, our primary functions were to signal to open, using the means of lever, spring, pulley, and gears. And lastly, the primary function was to protect the interior components of the mechanical designs, whether that be the means of cardboard, PLA 3D parts, acrylic, or MDF board.
So now onto the concept that we generated. We basically took, for every function, we basically took one mean for every function in order to create 20 concepts. And 3/4 of our concepts were based on Arduino since we were more comfortable with Arduino, and then the other fourth were mechanical. These are some influences that we had when making our concepts, and just some influences that we had. So as you can see, like this one uses a battery and has a sensor. It's made out of cardboard. This one's using a button. This one's using a sensor made out of wood, and then this one's using a sensor with cardboard. And all these are also Arduino-based designs since we're more comfortable with Arduino. And we use these concepts that are generated in order to create, in order to get to our top 5 concepts and then to our top concept. So we had to use a comparison table, and in order to, fully compare every concept. And also we picked all these concepts because they didn't have wood. They each used a different motor since we wanted different possibilities. They had no buttons, and we just made different, or we just picked them based on what we're more comfortable with. So as you can see over here, this is how we compared our top 5 concepts. Concept 2 won, but also we took other considerations. Even though we based it off of how marketable, appealing, cost-effective, and safe it is, we took out 10 and 12 since they used a battery, and we wanted to use USB as we thought that was more comfortable with us, as it's more reliable in case a battery dies. And 4 and 5, they used a DC and a stepper motor. We wanted to use a servo motor since we're more comfortable with that. And also took off 4 since of electrical tape. We didn't think that was appealing. And that led to our top concept, which was concept 2. It uses a sensor. It's made out of cardboard. It uses Arduino. It uses a USB. It has a breadboard, and it uses a servo motor. So these are all the ways we came to our top concept, which is concept 2.
After determining the top concept, the next step in the design process was to develop a CAD model in order to visualize how our box would look in real life. Out of all of my teammates, I was the one assigned with this task. I made an assembly in SolidWorks, and as you can see in the image, the assembly contains 8 parts. Out of the 8 parts, 3 of these parts I designed on my own. The other ones, I imported files from GrabCAD. These include the Arduino, the breadboard, the ultrasonic sensor, the spring, and the servo motor. The ones that I made include the bottom of the box, the lid, and the ledge. These parts are made out of corrugated paper in order to mimic the cardboard that the box will be made out of in real life. Although it looks like the box has quite a good number of parts inside of it, there are actually a few parts that are missing. The first part that is missing is the USB. This is simply due to the fact that I could not find a USB on GrabCAD that mimicked the one in our Arduino kits, so I decided to leave it out. The other 2 parts that are missing are the LEDs and wires. This is because we are not sure in the end how many wires in the LEDs will be used, so I decided to leave them out. We will instead decide in the end when we make the box in real life. This next slide contains a video of the box assembly in SolidWorks. As you can see, there is a little indent on the side of the box, and that is so that the USB can connect to the Arduino. The way it works is that the USB is plugged into the computer, and we will have code that programs the box. When something moves by the ultrasonic sensor, be it a hand or whatever else, the box will then become activated. The servo motor will turn on and hit the spring, and the spring will propel the box to open. The spring is simply just sitting on a little ledge in order for it to be close by to the lid. In the end, this project helped us learn more about the design process. We were first tasked with the problem of making a box that opens without direct intervention. In order to complete this task, we had to look at the different objectives and constraints we were dealing with in order to see what kind of box we can make. We then made a functional analysis and used a function tree to determine different kinds of boxes that could be made. We then used this to help generate different concepts of boxes. Ultimately, we compared our concepts and decided on one that we would like to use. We then decided to make a CAD model in order to visualize how this top concept would look in real life.